All right, guys, so we're going to get away from triangles for just a bit. Don't get too excited because they're still coming back. All right, so today we're going to talk about quadrilaterals and parallelograms. There are special properties that go with them. You are expected to remember them, okay? So first thing we're going to talk about is that quadrilaterals, here are some examples. Notice they all have four sides. So we've got four sides here. We've got four sides on this one, four sides on this one, and then notice this, there's 1, 2, 3, 4 sides, but notice it's not closed. So not a quadrilateral. This one has 3 sides and a curve, not a quadrilateral. 1, 2, 3, 4, 5, 6 sides, not a quadrilateral. So guess what the properties are? Properties are they have 4 sides. And guess what the other property is? The interior angle sum is 360 degrees. Okay, so type that up for you so you can read my handwriting. All right, so they have 4 sides and the interior angle sum is 360 degrees. All right, moving on. Now, there are certain properties about a parallelogram, and notice we have 5. There's 4 right here, and then there's the main one, okay? You have to know them all, all right? So this is where you're going to have to start memorizing. So for starters, the definition, a parallelogram is a quadrilateral, 4 sides, with 2 pair of parallel sides. So AB is parallel. AB is parallel to CD. So AB is parallel to CD, and BC is parallel to AD. So that one's pretty easy. Okay. The next property you need to know is opposite sides are congruent. AB is congruent to CD, and BC is congruent to AD. Okay. You also need to know that opposite angles are congruent. So angle B is congruent to angle D. Angle A is congruent to angle C. So angle A is congruent to angle C, angle B is congruent to angle D. All right. Now the next thing you need to know is that consecutive angles, which means one after the other, like we count consecutively, 1, 2, 3, 4. Well, angle A, consecutive to angle A would be angle B or angle D. Okay, so if we're looking at angle BAD, we're looking at this angle right here. Okay, so consecutive means neighbors. So angle ABC, so angle ABC, these two angles would be supplementary, which means they add up to 180, which would make sense because if these two are parallel, this is your transversal, these two are same side interior, and remember same side interior are supplementary. So make yourself a note, same side interior angles. Okay. So now if we look at BAD again, then we're going to talk about, so we're still talking about this angle A right here. So now I know BAD is next to ADC. Okay, so angle ADC. Okay, well what about angle BCA? BCA, so that would be this one here. It's going to be supplementary to angle CBA. And it's also going to be supplementary to CDA. So notice the next one says CDA. So it's going to be supplementary to, I'm going to go with BCD, sorry. All right, so same side interior angle. So opposites are equal, neighbors are supplementary. All right, and the diagonals bisect each other, okay? So if I drew a diagonal in here, so from A to C, and then I draw the diagonal from B to D, okay, they intersect right here. So we'll call this point E. So I know this one is congruent to this one. This one is congruent to this one because they cut each other in half. So BE is congruent to ED. And AE is congruent to EC. Okay, so those are your properties. Star this, that it's so important because you have to know these. All right, so now we're going to take those that we know with this picture and we're going to answer all these questions based on this given information. So since it's a parallelogram, that means this side equals this side equals this side. That means this is equal to this because the diagonals bisect each other. This piece is equal to this piece. And it also means that this is parallel to this, and this side is parallel to this side. It also means this angle is congruent to this angle here, because remember opposites, and then this angle is going to be equal to this angle. Okay, so now I've got all that labeled with the marks. So now let's just put these numbers in. So LM, I'm going to change colors. So LM is 86. So if that's 86, then JK is 86. LK is 100. So if LK is 100, then JM is 100. Angle JML. So this whole angle is 62 degrees. So that means this angle over here is also 62 degrees. JO is 5. Well, then OL is 5. MK is 15. MK, the whole thing is 15. Well, if the whole thing is 15 and you got two equal parts, so that means 15 divided by 2 is 7.5. So that makes this 7.5, and that makes, not 17, that makes this 7.5. Now find each measure. Okay, well, what do we know about neighbors? We know they're supplementary. So if I did 180 minus 62, I get 118. So that means this angle is 118. So this angle up here is 118. So now I think I have everything labeled just from these few things. So JM is 100 millimeters. Don't forget your units. KJ is 86 millimeters. Angle MLK, we found that to be 118 degrees. JL is a segment. JL, where's JL? JL would be this whole thing. Well, if that piece is 5 and that piece is 5, well, the whole thing is 10 millimeters. Angle KJM, that's 118 also. Angle LKJ, that's 62 degrees. OL, we found that was 5. And OK is that piece there, so that's 7.5. So I was able to find all of this, and all I had to do was two things. I had to divide here to get half, and then here I just had to subtract to get my neighboring angles. All right. Now we've got find the measures of x, y, and z. So they've only given me two things, but I know that opposite angles are congruent. So I know that z is 115. Okay. And since this is a parallelogram, that means this side is parallel to this side. So this is a transversal. So that means this angle is congruent to this one over here because they're alternate interior. So that makes y 30 degrees. So now that means if this is 115 and this one is 30, then this is a triangle which has 180 degrees. So if I take 180 and subtract 115 plus 30 is 145. So if I take 180 and subtract 145, I should get 35. So that means x is 35 degrees. Oops, 35 degrees. Okay? All right. Now this one, it says given parallelogram ABCD, find each measure. Well, since it's a parallelogram, we know this side is parallel to this side, so this is acting like a transversal, so these would be same side interior angles. So since they're same side interior, that means when I add them together, 4x plus 7x plus 15, they're going to equal 180. So I add my like terms. So 11x plus 15 equals 180. Subtract the 15. So I get 11x equals 165. And then I divide both sides by 11. I get that x is 15. So x is 15. Okay, number 6. Okay, we're going to add two things in here because they're missing some information, I think. So we're going to go ahead and find it. So given that parallelogram ABCD, find AE and AC. So they want us to find AE and AC. We're also going to find BE and BD. Okay, so we're going to find those also. All right, so since this is a parallelogram, the diagonals bisect each other. So that means this piece is equal to this piece. So that means 4x minus 6 is equal to 3x. So if I subtract 3x from both sides, I get x minus 6 equals 0. And then if I add this 6 to both sides, I get that x is 6. Okay, so if x is 6, this would be 3 times x. So 3 times 6 is 18. So if this piece is 18, then this piece is 18. So BE is 18. So the whole thing is 18 plus 18 is 36. So this would be 36. Okay. Now, since they bisect each other, that also means this side is equal to this side. So now I've got y plus 10 is equal to 6y. So if I subtract the y from both sides, I get that 10 is equal to 5y. Divide by 5, and I find that y is 2. So if I plug it in, this would be 6 times 2, which is 12. Well, if this side's 12, this side's 12 because they're equal. Plus 2 plus 10 is 12. So AE is 12, so the whole thing is 24. So you had to do two separate equations depending on which sides. Just make sure you set the right sides equal. All right, on your paper it says 0, 1. It should be -1, so there's a small typo. Okay, so what we're going to do here is we need to find the coordinates of the intersection. Well, think about this. If we go back here, the intersection of these points, wouldn't this point be considered your midpoint because you're equal on both sides? So what we're going to do is, since we have parallelogram ABCD, and I'm going to draw a parallelogram. Okay, so let me see if I can get this thing to lean. I might not be able to. And we need to, all right, oops. Let's see if we can get it to lean a little bit. So I can't get it to lean, so I'll just have to go with the freehand. All right, so we'll go with the freehand. All right, so we have a parallelogram, so we have this grid. We plot the points 2, 5, so if I go over 2, up 5, over 6, up 6, over 4, up 0, and, oops, that should be about right there, not that one, and 0, -1, which would be about right here. So we've got A, B, C, and D. So now when I connect the points, yeah, this doesn't look like a parallelogram, but we're going to pretend it's pretty. Okay, this is a parallelogram because they're telling me it's a parallelogram. So that means AC and DB need to intersect right here. So I just need to find the midpoint. So if I find the midpoint of AC, remember midpoint is to add your x's. So the x's are 2 plus 4 and then divide by 2. So 2 plus 4 is 6. 6 divided by 2 is 3. And then do the same thing with the y's. 5 and 0. 5 plus 0 divided by 2. That would be 5 divided by 2, which is 2.5. So that is where the midpoint is. Okay, and double check it. That's how I found that mistake. I'm going to do the same thing with B and D. So I'm going to add the x's. So 6 plus 0. 6 plus 0 divided by 2. 6 divided by 2 is 3. And then do the same thing with the y. 6 minus 1. So you have 6 plus negative 1 divided by 2, which is 5 over 2, which would be 2.5. So I double checked. So they intersect right there at 3, 2.5. So this is the midpoint. All right. Now, this is a caution for you to watch out for. In some parallelograms, the diagonals appear to bisect the opposite angles, but this is not always true. Okay, not always true. All right, so we'll start.